small voltage on the neutral wire going to a ground fault circuit interrupter, or GFCI, can indeed prevent the test button from working properly. To understand why, it's important to know how GFCI test buttons function. GFCI test buttons work by simulating a ground fault. This is achieved by sending a small amount of current through the GFCI's internal test circuit. If the GFCI is functioning correctly, this simulated ground fault current will cause it to trip. However, if there is a small voltage present on the neutral wire, it can interfere with this process. The neutral voltage can effectively cancel out the test current that the GFCI's test circuit is trying to generate. This cancellation prevents the GFCI from tripping, making the test button appear unresponsive. To troubleshoot this issue, firstly turn off the power to the circuit by ensuring the circuit breaker or fuse for the bathroom circuit is turned off. Secondly, check the neutral wire using a voltmeter to measure the voltage between the neutral wire and a known good ground, such as a water pipe or the electrical panel. If you detect any voltage present, it indicates a problem with the neutral connection or bonding. Thirdly, tighten all connections because loose connections can often cause voltage issues. Therefore, tighten any loose screws or terminals in the junction box for the GFCI. Fourthly, install a new GFCI. If the issue persists after taking these steps, try replacing the GFCI with a new one to rule out a faulty device. To elaborate further, let's consider the electrical principles at play. A GFCI constantly monitors the current flowing through the hot, or line, wire and the neutral wire. Under normal circumstances, these currents should be equal. However, if a ground fault occurs, such as someone touching a live wire and providing a path for current to flow to ground, a portion of the current will return through a path other than the neutral wire. The GFCI detects this difference in current, even a very small difference, and quickly trips the circuit to interrupt the flow of electricity, preventing electrical shock. The test button on a GFCI is designed to mimic this ground fault condition. When pressed, it creates a small current imbalance between the hot and neutral wires within the GFCI itself. This imbalance should trigger the GFCI to trip, confirming that the device is working correctly. Now let's delve deeper into why neutral voltage can disrupt this process. Ideally, the neutral wire should be at or very close to 0 volts relative to ground. This is because the neutral wire is connected to the ground at the electrical panel, creating a common reference point. However, in real-world electrical systems, the neutral wire can sometimes carry a small voltage due to various factors such as voltage drop along the wire, unbalanced loads on the circuit, or issues with the neutral connection at the panel. When a neutral voltage is present, it can interfere with the GFCI's ability to accurately detect the small current imbalance created by the test button. The neutral voltage can either partially or completely offset the test current, preventing the GFCI from tripping. Think of it like trying to push a swing with one hand while someone else is gently pulling it back with the other hand. If the pulling force is strong enough, it can counteract your pushing force and prevent the swing from moving. Similarly, the neutral voltage can counteract the test current, preventing the GFCI from tripping. The acceptable level of voltage on the neutral wire is very low, and any significant voltage indicates a problem that needs to be addressed. A properly functioning electrical system should have a neutral that is very close to ground potential. If you measure a voltage between the neutral and ground, it suggests a wiring issue, a loose connection, or a problem with the grounding system. The troubleshooting steps outlined earlier are designed to identify and resolve these issues. Turning off the power to the circuit is the first and most important step for safety. Always disconnect the power before working on any electrical wiring to prevent the risk of electric shock. Checking the neutral wire with a voltmeter is crucial for diagnosing the problem. A reading of 0 volts or very close to 0 volts is expected. If you measure a voltage of several volts or more, it indicates a problem that needs to be investigated further. Tightening all connections is a simple but often effective solution. Loose connections can create resistance in the circuit, leading to voltage drops in neutral voltage. Ensure that all screws and terminals in the junction box are securely tightened. It's also a good idea to check the connections at the electrical panel to make sure they are tight and corrosion-free. Replacing the GFCI with a new one is a good way to rule out a faulty device. GFCIs can sometimes fail, and a faulty GFCI may not respond correctly to the test button, even if the neutral voltage is within acceptable limits. If you have tried all of these steps and the test button still does not work, it's time to consult a qualified electrician. There may be a more complex issue with the electrical system that requires professional diagnosis and repair. Here are some additional considerations for troubleshooting GFCI issues. Check the wiring carefully to ensure that the hot and neutral wires are connected to the correct terminals in the GFCI. Incorrect wiring can prevent the GFCI from working properly. Make sure that the GFCI is properly grounded. A good ground connection is essential for the GFCI to function correctly. Check the grounding wire to ensure that it is securely connected to the grounding terminal on the GFCI and to a known good ground, such as a metal water pipe or the grounding bus bar in the electrical panel. Inspect the wiring for any signs of damage, such as frayed insulation or broken wires. Damaged wiring can cause shorts and other electrical problems that can interfere with the GFCI's operation. If you suspect a problem with the electrical panel, such as a loose neutral connection or a faulty breaker, it's best to call an electrician to inspect and repair the panel. Working on an electrical panel can be dangerous and should only be done by qualified professionals. Consider the age of the GFCI. GFCIs have a limited lifespan and may need to be replaced after several years of use. If the GFCI is old, it may be more likely to fail. Use a GFCI tester to verify that the GFCI is functioning correctly. A GFCI tester is a small device that plugs into the GFCI receptacle and simulates a ground fault. If the GFCI trips when the tester button is pressed, it indicates that the GFCI is working properly. If the GFCI does not trip, it may be faulty and need to be replaced. Be aware of other appliances or devices on the same circuit. Sometimes problems with other appliances or devices on the same circuit can affect the operation of the GFCI. Try unplugging other appliances or devices on the circuit to see if it resolves the issue. If you are unsure about any aspect of electrical wiring or troubleshooting, it's always best to consult a qualified electrician. Working with electricity can be dangerous, and it's important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any electrical wiring and use appropriate safety equipment such as insulated tools and gloves. Here are some common causes of neutral voltage. Unbalanced loads on the circuit can cause voltage drop on the neutral wire. This is more likely to occur on circuits with heavy loads, such as those serving appliances like refrigerators or air conditioners. Loose neutral connections can also cause voltage drop in neutral voltage. This can occur at the electrical panel, at junction boxes, or at receptacles. Problems with the grounding system can also contribute to neutral voltage. A poor ground connection can prevent the neutral wire from properly returning current to the electrical panel, resulting in a voltage difference between the neutral and ground. Electrical noise can also induce voltage on the neutral wire. This is more likely to occur in areas with high levels of electromagnetic interference, such as near industrial equipment or radio transmitters. Improper wiring can also cause neutral voltage. For example, if the hot and neutral wires are reversed, it can create a voltage difference between the neutral and ground. In summary, a small voltage on the neutral wire can prevent a GFCI test button from working properly by interfering with the GFCI's ability to detect the small current imbalance created by the test. Troubleshooting steps involve checking the neutral wire for voltage, tightening connections, and replacing the GFCI if necessary. If the problem persists, consult a qualified electrician. Remember that electrical work can be dangerous, and it is important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any electrical wiring, and use appropriate safety equipment. Following safety precautions and systematically checking the wiring and connections are crucial for resolving GFCI issues and ensuring electrical safety. Additional details to consider include the type of wiring used in the circuit. Older wiring systems may have degraded insulation or loose connections, which can contribute to neutral voltage. The length of the circuit can also affect the voltage drop on the neutral wire. Longer circuits are more likely to experience voltage drop due to the increased resistance of the wire. The presence of other electrical devices on the same circuit can also impact the GFCI's operation. Some devices may generate electrical noise or harmonics that can interfere with the GFCI's ability to detect ground faults. Consider using a dedicated circuit for the GFCI if possible. This can help to minimize the impact of other electrical devices on the circuit. A dedicated circuit has only one device, such as a GFCI receptacle, and no other loads are connected to that circuit. Regularly inspect the GFCI receptacles in your home to ensure that they are functioning correctly. Test the GFCI receptacles monthly by pressing the test button and verifying that the receptacle trips. If the GFCI receptacle does not trip, it may be faulty and need to be replaced. Keep in mind that GFCI receptacles have a limited lifespan and may need to be replaced after several years of use. The lifespan of a GFCI receptacle can vary depending on the quality of the receptacle and the conditions under which it is used. If you live in an area with frequent power surges or voltage fluctuations, your GFCI receptacles may need to be replaced more frequently. Consider using surge protectors to protect your GFCI receptacles and other electronic devices from power surges. Surge protectors can help to prevent damage to your electrical equipment caused by power surges. When replacing a GFCI receptacle, be sure to choose a receptacle that is rated for the appropriate voltage and amperage. The voltage and amperage ratings of the GFCI receptacle should match the voltage and amperage ratings of the circuit on which it will be installed. Also, ensure that the GFCI receptacle is listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. This listing indicates that the GFCI receptacle has been tested to meet safety standards. Do not attempt to repair a faulty GFCI receptacle. GFCI receptacles are complex devices and should only be repaired by qualified electricians. Attempting to repair a GFCI receptacle yourself can be dangerous and may void the warranty. When working with electrical wiring, always follow the National Electrical Code, or NEC, requirements. The NEC provides detailed guidelines for electrical installations and safety. Familiarize yourself with the NEC requirements for GFCI receptacles and other electrical devices. If you have any questions or concerns about electrical safety, consult a qualified electrician. Remember that electrical work can be dangerous, and it is important to take precautions to protect yourself from electric shock. To reiterate, always turn off the power to the circuit before working on any electrical wiring, and use appropriate safety equipment such as insulated tools and gloves. By following these guidelines, you can help to ensure that your GFCI receptacles are functioning correctly and that your electrical system is safe.